So I think we have our next speaker, Jeff. Let's see. Jeff, bring up your audio and video. Let's make sure that works.
My audio is on. Can you hear me?
I can.
And now my video is on?
Yes, you are live.
Okay, now all I got to do is figure out how to get my presentation to start.
Okay, I'll help you with that. First of all, welcome aboard and thanks for being here.
And let's change the name because that's not Jim.
Yeah, let me do that. Let's see. Okay, so it's Jeff. What's your call, Jeff? W2FU, Fox United, right? Yes, yes, yes. I've worked you many times. I should know that. Okay, renames. So now you're you. That's great. You're you. Yeah, your sharing looks great. Your logo looks wonderful. And
take it away.
I would say that the stage is yours. Go for it.
Okay, thanks. My name is Jeff. I'm W2 Fox United. GreenHeron Engineering is my brand. What I want to talk about today, however, is probably not the most familiar of our products, which is our rotor controllers, but I want to talk about GreenHeron Everywhere, or what we call GH Everywhere. It's been around for some time, and we've been using it for some time, and it's been gaining a lot of traction, especially now with remote operations, and it kind of exploded in the past year with circumstances. So to start with, what is it? GH Everywhere is essentially an antenna control and automation system. It's designed to do a number of things. It stands out in the remote environment, but it works locally, and it's for controlling everything in your station except your radios. It's for all that other stuff. Everybody's radio has a way of remote operation these days, and this does everything else that the radio doesn't do, like switch your antennas, turn your antennas to the right direction, and provide as much automation as possible. What actually is it? It provides for local or remote operating for your antenna and switching needs. It can turn accessories on and off, or your rotators, or anything else that can be controlled with a switch or a relay. And it's independent of your radio. So, and in most cases, independent of the actual switching devices. It's the control part. It's not the switch. It's not your remote coax switch. It's not your stack match. It's not your antenna. But it is the way, a mechanism of controlling it all under one application to enhance your operating. What are the advantages of this entire system? Well, it gives you local or internet control. It's identical, an identical operating experience, whether you're in front of your radios or whether you're in a different country operating your radio remotely. Everything operates exactly the same. It eliminates all tethered control switches and cabling to those switch boxes. That allows you to move operating position features or anywhere around your station or anywhere you want to operate from without having to drag switch boxes, what I call blue boxes, or push buttons and all the umbilical cords that go with it. And it greatly reduces station clutter. It automates the switch selection or antenna selection based on radio frequency. It easily integrates with almost any switching device. Anything that can be controlled with a line that goes high or low can be controlled with GH Everywhere. Your own homebrew stuff or our own line of switches. And last but not least, it optionally allows you to wirelessly connect your antenna switches to your station and get rid of the control cable all the way to the tower or wherever your antennas are. That promotes flexibility in where you might place your switching, because all you have to worry about is your coax line. Eliminates control cable all the way up to the field. You claim up to a mile range. We regularly run more than 1,000 feet. I've got some customers running a lot longer than that. Because you eliminate a control cable, you're removing one more source of lightning entrance into your station. And with copper prices the way they are today, you may find that just not putting copper in the ground pays for the entire system. What do I mean by automation? Well, the automation of your antenna switching is all based on frequency from the radio. But because this is a software-centric system, or most of the intelligence is in software, there's no need for band decoders. It works with any radio. It gets its frequency from the logging program that you're using to log, which is already talking to your radio. Because it's software-based and not band decoder-based, we get 1 kilohertz resolution. So you can use it for many things besides just band selection. One thing we've done with it is to be able to tune an 160 meter vertical as you go up in certain segments of the band, just based on the frequency of the radio. It gets its frequency directly from a number of sources, primarily N1MM, Windtest, DX Labs, N3FJP, or FR Stack for flex radios. And indirectly, you can get frequency from just about anything else that's available through a third-party program from Cadret, YO3DMU. You may be familiar with PST Rotator. Does a lot more than just handle rotators. What it does for us is it knows how to read the frequency from just about any readable device or program available and converts to N1MM format UDP packets, so we know the frequency as well. And what does it automate? It automates the on-screen displays to show what devices or switches are active. And it can actually switch positions based on frequency. More recently, we added the ability to tune a tornado tuner based on frequency with the addition of a small controller. And you can automate the actual turning of rotators through the Alt-J if that's supported by your logger. This is a photo of one of our stations during NAQP. You might notice this is a fairly sophisticated system we have. It's 4 towers, 12 rotators, maybe 40 different switching devices in active use at any time. This is the operating position, or one of the 2 operating positions. If you notice, there's no clutter. There's no switch boxes, no rotor control boxes. Everything is on screen. The only thing in front of the operator is their keyboard and the radio and computer screen. Because there are no switch boxes to pull around or rotor boxes to pull around, we can repurpose any position to any particular band or set of bands or type of operating without changing anything. All we have to do is reconfigure the software in a few seconds, or just pick a different operating mode and off it goes. This is a very competitive NAQP contest station, and you can see that there's plenty of screen space left over, even though we have a lot of antennas to control. We typically like to use N1MM for logging on the left screen, and the GreenHeron Everywhere switching devices on the right screen, but we'll mix and keep the mostly used stuff on the left and the leastly used stuff on the right. What are the components? Well, I call them building blocks, and they're fairly straightforward. The heart of the system is the server software, which manages all of the hardware switching and the connections from both the users and the hardware itself. And it doesn't require much of a PC. I'm running it on a Core 2 Duo, actually, at our station in New York. The client software runs at the operating position. Now, for small systems, single operator folks and DXers, They'll run their server software and their client is all in one, and it runs on the station computer, so there's no extra computer needs. As your system might grow, you may want to offload and have the server separate or run it with some other offloaded function in your shack. The clients themselves actually connect or actually are at the operating position. That's what controls the switches. It's what the user sees. And it talks to those switches through the server. And the integration between the logging software for frequency all comes to the client. Then there's two pieces of hardware. One is a small little box, we call it GH Wireless Base, and that's a USB device that hooks to the server, and a wireless remote, and that connects to your switching devices. And the thing that connects those two together is, guess what? It's wireless. So each base and set of remotes create essentially a wireless cable network. If you can picture this, a USB device that looks like, oh, I've got one slide ahead of me, so I'll get to that in a moment. But I forgot where I was. So let's continue and I'll get there. So because the system is modular and made of building blocks, it's completely flexible and scalable. From a simple station with a single coax switch and a rotator, or even just a coax switch, up to stations such as ours, which is 4 towers worth of antennas and 12 rotators, et cetera. It's just a matter of adding these little remote boxes as you grow to control various switching and rotor devices. You can add bases to a server, so you can actually add separate multi-point networks to reach different areas of the property. Or, for example, I use multiple bases. One is set to do all the inside switching. One connects to an antenna to the backfield for the transmit stuff, and another one connects to an antenna that goes to the front field. So we're covering about 12 acres, split in front and back, all with wireless control. There are separate RF channels you can use to prevent interference between different multi-point networks. You can have up to 254 remotes on each base. So this just keeps expanding and expanding. Now, there are some performance limitations trying to go to that many. I practically run 20 to 30 of them on a base without a problem. You can have any number of simultaneous clients into the system for either remote or all locally. The clients and the server software is all designed to allow multiple access and sharing of all your antenna resources. The whole system is really based on open architectures. We've got customers that implement some of their own server software and some of their own client software. The wireless communication we use is 802.15.4, which is a industrial controls protocol. It's what Zigbee is based on, using the XB family of modules. You may be familiar with that. It's got a lot of hobbyist traction as well as industrial controls. Pardon me. All the commands that go between the computers, the client and the server, is all done with plain text over TCP/IP. To create your own client to set a switch is nothing more than sending a command that says set switch with the switch name and the position name, and off it goes. And the server even shows you what each command is as it comes on if you want to look at it. And all the configuration files, or I should say most of the configuration files, are in XML format, so that if you don't use one of our own editors to set up your configuration, you can set it up yourself using a text editor. The server itself, as I said before, is a true multi-server application. It is written in Java. So although we designed the whole system to run on Windows, we have run server on a Pi. I have seen it run on a Linux, but I actually ran it on a Mac too. As long as you can figure out how to run a Java program on those other platforms, GH Everywhere will run on it. The server manages and connects all devices, all rotor controllers, the bases, the cable right to the server, and therefore reach out to the field to hit the all the remote antenna switches you might have, all via USB. We've already talked about that. And the connections come in from the clients using TCP/IP, all in human readable text. We do offer optional user authentication for actually accessing the system from over the internet. Although the system is very secure, even without user authentication, there's not much anybody can do. You can't get a Unix prompt from it if you happen to find the right port. I've had my server on for almost 10 years now, and I've never had a problem. And I don't use user authentication. And the system does do full transaction logging, so every connection from every user and every switch change or rotor turn is logged and optionally written to disk for reviewing later if needed. The client software can run on the same machine as the server, and in fact, the server actually has a built-in client, so you really only need your one-station computer for your basic system. The client offer is the operator's view of the devices that the server is controlling. Every operator can configure and lay out his own screen and view and operating method. And again, although it's designed for Windows, it's possible to run it on other platforms as well. You will lose some of the nice integration features with the loggers, however, if they're on different platforms. The one that comes to mind is the ability for contesting with N1MM to have focus automatically return to an N1MM window if you happen to pick up a mouse and click something. The client integrates with your logging software for frequency control. And for contesters, you can do just about everything you need to do with programmed hotkeys instead of a mouse. Keeps your hand on the keyboard. And there's lots of customization. You can add your own map images for directional antennas, either switched or rotators, display sizes, colors, how big to make stuff so you can use touch screens, etc. What are the operator controls? The operator controls for rotators come either from your logger, from pop-up presets. I'm going to run through these because we're taking some time, and I do have pictures I can show you of this. You can use hotkeys. You can drag a mouse on a map, use a touch screen to turn any of the rotators. For switches, you can get automatic frequency control to select different switch positions, or use a mouse, or use hotkeys, or again, touch screen. Here's a little picture of the base. It's just a little box that's got the wireless stuff built into it. It's powered by USB. You get the box with internal or external antennas, low power or high power. The high power is 63 milliwatts. Again, the range, the advertised range for 802.15.4 with external antennas up to the limit of the FCC rules for unlicensed operation is about a mile. I'm running them 800 to 1,000 feet commonly. The small little convenient package shows signal strengths in the familiar yellow, green, green, green 4-bar format. You can actually connect a switch device right to a base. We typically don't recommend it because you lose the lightning barrier, or one of the advantages of having a wireless link to your antenna switches. There is a PTT jack on the front of each base, and if you desire to hot switch protect anything on that base, if you ground PTT while you're transmitting, it'll delay or pause any switching until the PTT sign goes out. The wireless remote looks very similar, except there's no USB plug on it. There is on the back, this is one of the IO modules that's available for an 8 relay output. It's a matter of wiring those 8 relays up to your switch device. It's 12 volt powered at the remote. It has 8 bits of control, which you can split. In other words, you can use one remote to operate 2 or 3 different devices, depending on the bit count you need. By bits, I mean output controls. There are a few versatile I/O modules. The most common is the 8 relay, but there are special applications where out of the 8 bits, you can have 16 plus voltage drive, 16 relay, or 16 NPN. Cute little thing is the ability of this whole remote and everything connected to it to go to sleep. It's a software setting. If you have a switch device that's out in the field somewhere and it's trouble to get 12 volts to it, you can run the thing on a small battery and a small solar panel and program it for sleep mode. The whole system will go to sleep if it doesn't hear from the base in 30 seconds. And if it doesn't, goes to sleep, then every 30 seconds it wakes up for 1, looks to see if there's a signal. If not, goes back to sleep. So for most amateur operating, you're not operating 24 hours a day, 7 days a week. So whenever you're not using it, you shut off your server and your power system in the field goes to sleep. Each remote can also support an RT21 rotor controller through a serial port that's inside the box. This is a package for the remote that's for outdoor use, where it not only adds the weatherproof enclosure, but it also adds a bias T for getting 12 volts through the coax. So you would put that remote device, you could put that outdoor right under your, say, your DX Engineering coax switch and wire it into the switch, and you've converted your existing coax switch to the wireless scheme and put it all available on the internet all in one shot. For rotators, rotator, I define a rotator as something that turns an antenna, and that's a distinction that needs a distinction, I guess. It's really an antenna because we also have, besides a normal rotator, a cloned rotator. A cloned rotator is for having the ability to see and control a second antenna that might be on the same mast, or a rotating tower that's starting multiple antennas at the same time, with or without an offset. If you're use the common practice of a tri-bander with a 40-meter beam above it, turn the 40-meter beam 90 degrees. We can support this as two different rotators. One's the real one, which is for your tri-bander, and the other one is the cloned one, which shows everything at 90 degrees offset, and everything works 90 degrees different. Your rotators may be directly connected to the server through USB or remotely through the serial port of a GH remote. When I put up my 10-meter tower 10 years ago, we did it for the express purpose of alpha testing this stuff. So I ran a piece of coax out there and that was it. It's right next to a little barn building, so you get power from it for there. But the rotator controllers, the stack matches, everything on the 10-meter tower are all out there on wireless. The displays for rotators are either digital, which we call a tray, or a map image, which you can use compass rose or your own images, and you can control it through pop-up presets. One nice little feature that's not used nearly as often as I would have thought it was the embedded stack controls. And this integrates a stack match with the actual antenna that the stack match is turning on and off. And it makes for a much better integrated system of showing what you're turning on and off when you're turning your stack match around. This is an example of a tri-bander in that 40-meter beam I was telling you about, where you have your 40-meter beam 90 degrees off. Your real rotator's in yellow. This is a cloned rotator, it's in blue. Now, depending on your preference, you may or may not show both of these at the same time. You have the option of turning only this one on when you're on 10, 15, or 20, and showing only this one when you're on 40 meters. It's in blue to alert you that it is cloned, but that's the only alert or change that's apparent. Any antenna position that's turned when you're on 40 meters is using the correct heading and the correct display. Typical presets frame. This is a map display. These are so cool, you could make a dedicated monitor to it and put your rotators displays up there. You can set what the beam width is. In this case, I'm showing both the 40 and the tri-bander with the 90-degree offset. In most cases, you probably wouldn't show them both at the same time. You can turn the rotator by dragging these wedges or using your hand on a touch screen. You could be running this client on a little tablet next to your station and operate it with a touch screen. By the way, that image I made with, I think it was no, it was, oh man, it escapes me. But the image I just made with a piece of software that I had, and you can put any image behind there. This is a tray of, this is a picture of what our system looks like on 20 meters, where we have a 3-high stack with individual rotators, and the green LEDs are the integrated stack control, and the little names divide, multiply, and subtract are the hotkeys assigned to that, which are the divide, multiply, and subtract keys on the numeric keypad. So I can turn on and off any of these antennas just by tapping those buttons or clicking on them. It's really cool because it shows you what antenna at what direction you're actually turning on and off, as opposed to having a rotor controller and a separate stack match control box sitting there and you're not really sure what you're turning on and off. For switches, row of buttons is the most common. You can select names and colors for whatever you want them to do. A band switch is a specialty button switch. It's a button switch that may be selected, have a switch position selected by the radio frequency. So it's an automated button switch. You can have an on-off bank, which is a set of buttons that you toggle on and off for accessory control. I'll show you a couple of uses of that in a minute. You can have a switch that's actually a directional antenna switch, like a 4-square or an 8-circle controller, where you want to have a map like your rotators, but it's for switching of antennas. Matrix lockout is a special version of a band or button switch that it's because with a matrix lockout, you're connecting it for a matrix antenna switch, like a 6-pack, or we use the Ham Plus 8x4 in our station, which is 8 antennas to 4 radios. You'll have, with an 8x2 or a 6-pack, you'll have 2 separate controls, one for the radio 1 and one for radio 2, and the controls will both be the same, except they operate different ports. You don't want them in the same box. You don't want them on the same screen. They'll be on different operator screens. They could be in different parts of the country, operating the same remote station that's using them. So the matrix lockout gives you a way of seeing what the other operators may have selected, so you can't take them. And it implements the first one gets lockout logic in case the switch you use or have built doesn't support that. And there's a virtual switch that I'll briefly just mention. It's a way to switch or define a button that will switch multiple different remote devices in different locations at the same time without having to switch two. For example, if you wanted to share a feed line, you had a rotary switch at one end and another remote switch at the other end, and you wanted to share that coax for different functions, you could have one button that feeds the two real switches to implement that. Button switch looks like this. A band switch looks very similar, except it has the software control on the bottom for radio A or radio B software control. And here's an on-off bank, a simple on-off bank. One of our remote systems that we use is a Flex 6600. We use the remote on for it. We can toggle the PTT to add operators without anybody at the station. Or we can turn our SPE amp on and off. So that's just a simple on-off control. The map display for switches would look like this. This is the default compass rose. You can put your own image behind it, just like we did with the rotators. In this case, this is an 80-meter 8-circle. We like to use hotkeys to rotate those around. You can call CQ and tap 66666 and rotate your 8-circle around and hear people calling you. The matrix lockout has 2 separate controls for an 8x2. It would have 4 separate controls for an 8x4. In this case, they're labeled run 1 and run 2. The antennas they select is obviously the same, but if run 1 has 80 meters selected, which is in green, it shows up in pink on the other station and they can't select it. Conversely, run 2 has 20, so it shows pink in over here. And the 2 operators that are using run 1 and run 2 may be in different parts of the country or the world. If they're operating a station that's running multi-2, for example. GreenHeron we do manufacture a couple of different switches where they're sort of specialized. One's an 8-position coax switch. Another one is an 8x2 receive-only switch. Both of these have the wireless built in. I'll show you a little bit more about these in a minute. For the Ham Plus matrix selector switches, we like these because they have very high isolation. They're easy to mount on a wall, and they're very easy to integrate with GH Everywhere because they use ground switching. And we can use a single remote to handle one 8x2, 2 remotes to handle an 8x4. And the last one is also a Ham Plus device. It's a 4-high stack controller that we went ahead and installed a GH remote board right inside it. So you essentially have a wireless stack controller. This is the select date with a representative control of what it would look like. This is the 8x2 remote coax switch, which allows you to not only select different antennas for the 2 radios, you could actually share the same antenna at any time by 2 radios. This is terrific for beverage selection. We use it for that, and we also use it to select what circle antenna is connected to what radio. This is the Ham Plus 8x2 with the displays I already talked about. And this is the package for a 4-high stack controller with the wireless built right in. You do have to supply 12 volts to this one. There's no power through the coax feature for this one. And finally, or almost finally, this is how, and I'm not going to show a whole lot of detail about how you actually specify all this stuff, but this is the heart. This is what I call a WIO profile, or a wireless IO profile. It defines all the switching devices that you would want to use. And of course, this is where most of the customization comes from. The name of the switch, the type of switch, which will give you the type of display it will have on the client, whether it's one of the specialty matrix lockout or virtual switches, the names of each of the settings that will show on your buttons or in your positions. If it was a directional switch like a map, you would put your beam width and the heading in here. The state of all of the outputs. This is the truth table for how the switch reacts when you select different positions. And for a band switch, the frequency ranges upon which that a specific position will be picked. And this is entered into the server for each device and sent to all the clients in form that they know what the devices are. One of the really cool things, well, I think the overall flexibility. You can start small, you can do just about anything. Our customers are constantly coming up with new thoughts of ways to use it that we don't have to change anything. It just by making a few interesting settings, you can make it happen. One thing that came to us is we needed an ability when we were operating remote this past contest season to be able to alert the other guy on the same band that you wanted him to be quiet because you were really close in frequency and you needed him to be quiet. So we put a little single button switch up there that lit up a light over his, or lit up a display right over his N1MM window. So if I needed the run guy to be quiet, I could just tap a hotkey, it turns that light on, and he knows to be quiet, and then I can turn it off again. So it's a way of actually semaphoring or communicating between the two operators. You can use custom images. The remote sleep mode is really cool. The cloned rotators offer all kinds of flexibility. I'm going to show you one of those. I think I have about 5 minutes to do that. The ability to hide and show switches and rotators based on the current band reduces the overall clutter for even complex systems. You can run 2 clients on one for those contesters that want to run SO2R. You can run radio to operate one set of controls and the other radio to run the other set of controls all on one computer. The virtual switch and the ability to share and use a single remote with its 8 relays to do multiple switching devices, and the hotkey shortcuts. With that, if I can figure out how to do this real quick. Am I still on?
Yes, sir.
Okay, good. I'm going to shut this down. And is my screen being shown?
Yes, the whole desktop.
Okay. I don't want to do that.
Are you going to play a video?
No, I'm going to actually bring up GH Client and log into my server in New York. I'm in Florida, by the way.
All right.
The station is in New York. I have everything hooked up except an actual radio here. I don't have my K3 Mini with me. But I'm going to actually show you our live system and what the operating experience would be like remotely. So hopefully you can see this.
Yes.
I'm on 20 meters. So I'm only showing my 20 meter stack controls and my 20 meter rotators. I've got a little map up, which is a little bigger than we normally keep it, but I wanted to show you that. I can rotate stuff by doing this. I can bring up a preset by clicking here, brings up the pop-up presets, turn that antenna to 98 degrees and it will go, hopefully. Yeah, there it goes. So that one, the mid went to 90 to 98. Let's say, oh, I need everybody to go towards JA. I click all 3 of these and do a pop-up to JA and off they go. One thing you notice is my N1MM never lost focus. These 2 switches are band switches that are automatically switching. So they went to 20. If I want to go to 15 meters now, I don't have a radio, so I'm going to change frequency this way. Now it moved most of my band switches to 15 meters. It brought up my 15 meter antennas instead of the 20. And likewise, when I go to, let's go to 40 meters, that's where things change a little bit. On 40 meters, I changed again my antenna selection for both transmit and receive. It brings up my beverage selector and my 8-circle selector and the 40 meter rotators, of which only one is an actual rotator. The gray ones are fixed antennas. So here's where I use a stack match, and I call this a rotator, but it's not, it's just an antenna. There's no rotator on the low 40, it's fixed at Europe. And the dipole is just actually, it's an inverted V, so I don't really care where it's pointed, but it's still into my stack match, and I can control that with a mouse click, or better still, with those little divide, multiply, subtract keys, I can turn specific antennas on and off and just run the high 40 meter beam without my hand leaving the keyboard. When I go to, let's go to 80 meters. Now it brings up a little button switch that lets me, I share the 80 meter feed line and can pick a dipole or the 4 square, or I can actually switch over to my 6 meter antennas. I now have added the transmit 4 square to the mix, which likewise works off a hotkey. I use the numeric keypad. I use the 7 and 9 to switch the transmit 4 square around. I use the 4 and 6 for the 8th circle, and I use the 1 and 3 for the beverages. So never have to leave the key. My hand never leaves the keyboard. I can listen in all directions. Now here's where it gets a little interesting. And this really shows the flexibility. Although I would never do this on the same radio, I do have another remote rig K3 setup that's set up for VHF. But I'm using the same GH Everywhere server with the same devices all plugged into it. So I'm going to go to 2 meters here. I'm going to move a few things out of the way because they're kind of in the way. But now when I went to 2 meters, I show only cloned rotators for 1, and that's because my VHF H-frame and dishes are mounted, face mounted on the rotating tower that's actually turning the 40-meter beam. So although this rotator, this little one right here, is actually turning the 40-meter beam, it's also turning my H-frame, and I don't even care where the 40-meter beam's going. But I do got a narrow beam width. Of course, the world map isn't too applicable anymore, so let's change the image and go to a grid square map. And here's where I like to have this one really big, because I use this all the time. I want to point it at Connecticut. I could point it at Connecticut, and off it goes. 6 meters are likewise cloned antennas. They're actually off the top 15, 180 degrees out, and off the bottom 15, 180 degrees out. And I'm going to show you a virtual switch, I think. Where'd it go? Well, I missed one. Let's see what happens. I went to 2 meters. These 3 switches are real switches. There's a virtual switch in here somewhere. And if I go to 222.100, that changed the virtual switch, which in turn changes my coax switch at the upper of a common feed line and the lower of a common feed line, and the 28 megahertz IF from the K3 out to the transverters. And all this stuff is out at the base of the tower, all on wireless controls. This one is actually up the tower at the top end of the feed line.
Jeff, this is John.
Yes.
I love what you're doing. It's this armchair control is beautiful. Everything you demonstrated is gorgeous. What I wanted to tell you is that there are about 10 really good questions waiting for you.
Okay.
In the Q&A section.
I'm done.
And I thought you might enjoy, you can leave your screen up if you want, because it's beautiful to watch and we get it. But let me start with a couple. There's
Sure,
Bob,
go right ahead.
Okay, Bob Wilson, N6 Tango Victor, has 3 questions for you. Bob, I'm going to allow you to talk because you can. So hang on. Yes, thank you for doing that. Click over here, unmute yourself.
Hello, Jeff.
Okay, the floor is yours, Bob.
Hello, Jeff.
Bob.
Talk a little bit more about the RT21 DC and control of the Tornado tuner. Does it work with existing 4-wire control cable? Can the pulse counter that it requires work wirelessly with your devices? And can the RT21 be programmed to move the Tornado when you QSY as little as 10 kilohertz, which is what I have to do?
Okay. Yes, and 1 kilohertz.
So it does. The pulse counter does work wirelessly. I'd have to go up and...
it could work wirelessly to the controller. You could put the RT21 DC out near the Tornado tuner if you like.
Okay, so the
And
DC
you
is
could operate it controlly, but wherever you have your current controller is probably where you want to put the RT21.
okay.
In this case, it's a DC powered RT21 because the Tornado tuner uses a 12-volt motor with almost no current.
Right.
And we just calibrate it pulse count versus frequency, and off you go.
Okay, so I could just plug compatible, replace my screwdriver controller with the RT21 DC controller, and the 4 wires will work the same?
Exactly.
Okay. And then second question regarding your RT21 rotator controllers. I've always been frustrated by them because if I send it one command to go to a certain heading and then, oh, I didn't want to go to that heading, I want to go to another one, it won't change, it won't stop and go the other direction or accept the new heading until it's finished. completing the first command, or you have to manually hit stop and cancel it, which is difficult. So,
Well, from most software programs, you can stop it.
right, but I don't, I just want it to accept the new command and stop itself automatically, pause for a while if necessary, and then go to the new heading instead of having to do a bunch of clicks to do what I want.
I haven't heard that much. But
For example, most analog controllers like the create controller, you turn the knob to one heading, it starts to go there, you twist the knob the other heading, it stops, pauses, and goes to the new heading. That's very convenient and what we really want.
yeah, it's interesting. The ASL controller has a feature that does that. It does it because it does look ahead. So you can, if you're tracking a fast-moving satellite, you can keep sending it new targets as it's turning.
Well, it's just a plea for you to add that to the regular rotator.
There's no reason why it can't go in there. That's a fairly new implementation in the ASL controller, and we're using the same processor chip and most of the same code. I'll put it on the list.
Thank you.
Yeah.
All right, next up is Bill Faring. Bill has 3 questions for you. I'm going to turn your microphone on, Bill.
Can you hear me okay?
Loud and clear.
All right, so I have a couple ones. So great presentation, Jeff. Thanks for everything. We use your stuff at N6RO, ND7K, and ZF1A. So anyway, I had a question for you. Do you have any chance that you are looking at building an outdoor hardened version of the RT21? And the reason I ask is because, you know, as you know, rotor control cables get long, they have a lot of voltage droop, they have lots of associated problems, and we'd love to just wirelessly talk to that.
Yeah, I actually had one running at my place for a while on the lower, one of the small 40-meter beams, or it was on a Yaesu rotator. I took an RT21 board, put it in a fiberglass enclosure, and stuck it at the base of the tower with a remote board in it. And it worked great. That's on my list. I am a one-man design shop, as I think you know.
Yep.
So it hasn't crept up the priority list very high, unfortunately. And I'll make one excuse here. During the pandemic, during all last year, I did all the shipping and myself, and had to furlough my shop tech. So I didn't have much time to do development, but it's on the list.
Fair enough. Fair enough.
If you wanted to make one, you could take a board and stick it in an enclosure, and it works. I mean, the device itself is hardened. Every component in an RT21 is industrially rated. The only thing that you'd have trouble if the temperature goes well below freezing is you wouldn't be able to see the LCD display anymore, but you won't have that problem in Cayman.
Probably not, no. Okay, so we've had a couple of other situations that have kind of crept up, and I know that they're a little specific, and if you want, I could go to email on them, but so I'll just give you one of the scenarios here. We had a 3-position stack match, and the middle antenna, you know, had an issue for a little while. What I couldn't find is a good way to disable it such that no operators could turn it on in the shack accidentally. I mean, if you remove it, that messes up your the positioning of the stack match and how you're sort of associating which position with what on the stack match. So I'm wondering if you have any good solutions to that.
I'd have to think about that.
No worries.
Yeah, I got it written down though.
Sure, and then I have one more for you. So you used to have a GHE knob that would let you. It had an encoder, a
Yep.
rotary encoder on it. Yep. And I saw that kind of went away, but I've also had a little bit of resistance with some of the folks in the shack that would just as soon push buttons for a stack match on a physical box of some kind. Have you considered, or do you have any good solutions for people that would just as soon push a button?
The encoder that I had used for that went out of print.
I see.
And that's why I canceled it. At one point I did some other solutions, and I actually implemented a little chip and wrote the code to do the encoder. But again, that's one of those things that's on my list, but it hasn't bubbled to the top.
No problem. Thanks, Jeff.
Okay, you got two more waiting for you.
Okay.
Bill Carter, I'm going to open your mic. Are you there? Bill Carter? I'm not seeing, I see your hand, but I don't hear your voice. All right, Kirk Pickering, I've got you unmuted.
Hello, can you hear me?
Yes, sir.
Thank you, John. Thank you,
Yes.
Jeff.
You're welcome.
Long-time user of the RT20. I think I bought one of the first ones you offered at Dayton and solved a lot of problems I had with my tick rotator, all of them, in fact. My question is, does any of your software support the older RT20s, which have only, a legacy serial interface, or am I, and I'm talking about only really for calibration purposes. I don't really use them in an interconnected software world. I prefer to manually control the rotator, is what I'm trying to say. So does any of the software for the work for the RT20?
The RT20 is, of course, it's been discontinued for about 13 years now.
I knew it was old. I didn't know it was that old.
But I'll say
Come on,
that,
time for an upgrade, Kirk.
Yeah, I guess so.
we can install, let's see, the RT20 has gone through 4 generations. We're on the 4th generation of controller, and each generation has a more powerful and larger PIC processor chip. The 3rd generation chip can go on a 1st generation RT20 and bring it up to 3rd generation software control.
That's awesome, because that's my second.
It costs $25.
I'll sign up right now, because I actually have 2 of them, and one of them you repaired and you did upgrade it to the RT21 chip. And that was my question, and it's socket mounted, so I can just like field swap it, right?
The chip is socket mounted, but any RT21 processor with the limitations of the board, for example, your RT20 board has no USB connector. So you can't get USB functionality, but everything that works through USB can work with the serial port.
Excellent. I'll drop you an email. Thank you, Jeff.
Okay.
All right, I have a question. This is from Peter Meyer. If I set this all up and my server goes toast, what do I do?
Well, you don't operate.
Okay.
With today's reliance on computers, if your computer goes down, you pretty much can't operate anyway. I've got to say this: my server runs 24/7. I haven't been in New York in 3-4 months. You just saw me run it.
Yeah.
If you pick the right computer, don't go get a laptop from Best Buy to run as a 24/7 server. They're not intended to do that. Instead, you can go to one of the many outlets that have commercial grade computers that were used for point of sale on off lease, and for $100 to $250, you can pick up a suitable computer that has 8 USB ports, runs at least a Core 2 Duo, Windows 7 Pro or Windows 10, has all the power you need, and they're so rugged and reliable, it'll make your head spin.
Okay. And Chris Tate has a great advice. Save early and save often. Save your data early and save it often. Let's move on to another question because we're going to run out of time. Ray Higgins says, if and when the DX rotor is released, will the RT21 be an option?
Absolutely. It's already in the software.
Okay. And let's see. Steve, KG5 Victor Kilo, Steven Smith says, Jeff, can you expand on the multiply, divide, and subtract green icons on your rotator control panel? Do you know what that means?
Yes.
Okay.
These right here, right?
I guess, yes.
Those on my 20 meters, this is a stack controller. Now, it could be an Array Solutions. In my case, on 20, it's one of our Ham Plus ones. Essentially, the logic is built into the software that allows me to, if I tell the system through the device manager within the system that that we have a stack controller for the high, middle, and low 20s, it puts this stuff on the screen. And from that point on, by hitting the divide and multiply and subtract hotkeys, which I programmed, let me show you how you do that. You right click on this, it says assign hotkey. I assign the hotkey and I go divide. So now, which I had already done, the divide key on the numeric keypad turns on and off the upper 20-meter beam.
Okay, thank you for that demo. I think that was clear. Have last questions from Jeff Martin. Do you have Node-RED drivers for GHE everywhere?
I'm not sure why you would want them. I've talked about that. I mean, this does, I think, everything that Node-RED would do.
Then I would say, Jeff, why don't you send an email to Jeff Martin? Send an email to Jeff and he can answer you.
Yeah, if you let me know what it is you'd like to do, I could figure out how GH Client can do it, and then you don't have to write any code or do anything yourself.
There's a great answer. All right, I stopped your presentation because it's time to say thank you to you, and you filled out the hour really well, handled the questions very well. Thank you. Got a great product. It's very popular. It's very well made, and congratulations on your continued success. And thank you for being on our team today. We really enjoyed having you here, Jeff.
Thank you, John. See ya.
Okay.